Hey everybody, welcome back to my channel. A couple of things real quick. You may have noticed I changed the name of my channel from This Old Radio to Sam's Radio and TV. I thought it was a little more fitting. It's something that I've been always wanted that title. I don't really do radios anymore. They're boring. Can't do anything with them. And, you've heard this story 100 times. Anyway, changed my name. I've actually made 600 subscribers, and now I've can do a little bit of monetization now. I haven't played with it yet, but look forward to that here in the near future when I get a little time. Anyway, got a box in from FedEx today. Let me show you. eBay purchase. Something in here that very interesting, that one, which is going to make this right here interesting because it's a new piece of test equipment that I got to figure out where to put. So let me get you guys on a tripod and show you what let's unbox this and see what I got. Wow. It is a B&K Precision Model 415 solid state sweep marker generator. It's supposed to work. Who knows? Got a lid you can open up on it. We used to have one of these, if I remember right, at the place I used to work years ago. But I have never done a complete TV alignment. I tried doing it one time years and years ago when I worked in on television. But I was, I did one while I was in trade school, but I never done one after that. And I had one a TV set that I was trying to do in alignment. I never got it right, and I gotta make it work good. And I don't know what it is. Sometimes people just don't want to stop and take time to explain things to you and help you out, that's happened while I worked for TV. The guy didn't really show me a whole lot about how to do something or work with me. I guess I was expected to know it. And that's been like that on a couple of jobs that I've had. People don't show you how to do something when they actually see you struggling or trying to understand, and instead they just blame you for it not working later on. But anyway, let's take a look at this bad boy. A little shaky cam going on. I like the thing. I'm really a fan of B&K. This VTVM I got right here is like the one we had when I worked in the TV shop. I found an oscilloscope just like the one I had when I worked in the TV shop, and I thought about buying it, and I might do that. But let's look inside. Let's look at the front of this thing. You guys understand that I have not touched one of these since I was 20 years old. That's been 40 something years ago. Let's see what we got. External marker in. Let's look at something else here. This looks like audio right here, and then this is the IF response for your video. All your vestigial sideband right here. Here's your chroma right here for your color information. This is your sound right here, and that's where you trap it off at 4125. understand right and remember how that works. External marker in, spare marker, adjacent pick, sand, chroma, 4.08, 3.58, and 3.08. Tuner, 44 megs, 45 megs, pick, adjacent sound, 100 kilohertz. Bias supplies right here are 225 volt bias supplies right here. Looks like you can make it go positive or negative. These right here, 0 to 50 volts right here, plus or minus. Horizontal sweep to scope. These old microphone connectors, yes, they will be replaced with BNCs. Yes, sir. Markers, vertical, horizontal, amplitude, DMOD direct, or DMOD probe. The Iketo Zenith I had, you can come right off the video detector straight to this, and you don't need the demodulator probe. Normal, reverse for the oscilloscope vertical input. So what I like about this, it sends it all out, makes its own markers, and then it's really all you got to do is just put a signal, into the TV right here, demodulate it here on the detector side, and look at your scope. That's what I like about it. Let's see. Got your this is your sweep width, your sweep generator right here. We're going to have to get the manual out, and we're going to check this thing from one end to the other. See if it needs, check the frequencies on it, make sure everything's working right. Probably put the spectrum analyzer on it and the frequency counter and all this kind of stuff to make sure the power supply is good, all this stuff. So we're going to do this by the book. Make sure everything works. We'll change all these out to BNCs on there right there. Oh, and copyright 1968. Here's the insides of this bad boy. So we got a crystal, 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 crystal. So what is that? 1, 2, 3, 4, 5, 6, 7, 8, 9 crystals there. So what do we got here? 1, 2, 3, 4, 5, 6, 7, 8, 9 there, unless I miscounted. And there's an extra one that I'm probably not seeing, and that could be, who knows. Don't know much about these things. It's been years since I touched one, so now I've touched it. I like the cover on here. It's got what looks like a little bit of surface rust on it. Don't know where I'm gonna put this bad boy. A lot of people put their test equipment over in storage and they take it and bring it out when they need it, which in my case I'm about storaged out, but we'll see. I'll figure that out. But there we are. Like I say, I don't know much about this thing. I guess I could put you guys down for a minute, turn you guys off, and we'll hook up, get the spectrum analyzer out, put it on here, and just see what comes out of it, and then we'll hook up an oscilloscope and just play with it a little bit, check the frequency, power supplies. It's got power supply transformer right here. There's your rectifier section right there. Then it's got a big electrolytic cap right here, which is loose. Yeah, you hear that, right? That's loose. I don't know what's up with that. You got 1, 2, 3 big electrolytics there. It looks rather clean. Something right here, I don't know what that is. A cut off wire. Huh. Well, I don't know. Let me see if I can get to the inner workings of this, which may be able just to reach the bottom panel on the bottom, I guess. Let's see what it looks like underneath. Yeah, if Mr. Carlson can take something apart, everybody's watching, I guess I can too. There is a bottom panel, and got little rubber bumper feet. It's got screws in it, which is part of the screws that retains the panel. Not really bad. It needs a good cleaning. It might need the top repainted. More torque. There we go. Doesn't look like it's been molested. Now that I got it, I get all molested. I'll tell you, that old Zenith television I had, that thing, after I finished the video and everything, I said this is a wrap on that one. I noticed that it's losing horizontal drive. It had a bad speaker. The speaker, when I put it in the cabinet, the speaker was bad. And it was losing horizontal drive. It was starting to fold in on one side, so which I understand is low drive. And then you know what? I ain't fooling with that thing no more. The yoke is questionable. It's just time to retire it. Somebody's always texting me. Alright, let's have a look at this thing. Get y'all down here. Let's see. Oh my word. I think text messages are the bane of civilization. Well, let's get a light and a pointer. Let's have a look at it. And you'll see. Well, here's the electrolytic right here that I said was leak. Oh my God. Let me do that again. Here is the electrolytic that I said was loose. Y'all gotta see this. Let me find it. Yeah. I gotta zoom you in. I gotta get a vantage point that you can actually see. There we go. Pull you up just a little bit. There we go. Alright, once the camera decides to stabilize, alright, I'm going to wiggle it. See it? Now that's a first class connection right there. Yes sir, that's a first class. So, let's have a look at this thing. By the looks of how this wiring is all done, don't look right, does it? That look like that should have all been tied down neat and orderly. I can't believe it would just come out of the factory like that. So something's been going on here. Let's have a look at these pass transistors or whatever they are. Trying to look for Circuit boards don't look like they've been molested. All in all, there's my flashlight going bad. This is the story of my life today. Everything I've been around is just going bad. Anyway, it don't look bad. I just don't trust this wire, because like this cable right here is going to this switch. I wouldn't think it would just be intertwined and all this kind of stuff, but you see all this stuff look like it should have been zip tied together or some kind of. That is definitely loose. I bet that worked really good. Wonder if it's good or not. Doesn't look like it's been changed. It's just crappy soldering joint. I'll fix that for sure. I can fix that. We'll take all that bad solder off of it, clean it up, put a little flux, you know, put a little alcohol it up a little bit, put a little flux on it, resolder it with a heavy duty soldering iron. That should be good to go. But as you know, I'll probably pull these leads off of it while I'm at it and check that capacitor. So, there you are. I guess we'll fix this capacitor first, like I said, and see if it's good, and then we'll move on to testing it. I'll tell you, let's do another thing. Let's check this fuse. I don't know what size fuse is supposed to be in here, but that is a little fuse, man. Whew. I have to get my glasses out for that one. Put on my spy glasses here. I'll see. Trust me. It says here a half amp at 250 volts with a little 3AG fuse. Looks like it's intact. So it's a shorted fuse. Good or bad, a shorted fuse, y'all decide. Don't know what it is, but I would think if somebody put a fuse in here that wasn't supposed to be in here, it'd probably be bigger. So I imagine a half amp fuse is probably normal for this thing. So, see the line cord. Looks intact. Nobody cut off the third wire ground right there. Very pliable. I don't see any nicks in it. So this appears to be the power supply board. I see something here, 25 plus 25 volts. It's like minus 25 volts here, so I got a plus 25 and a minus 25, which is probably what these two transistors are right here. Is a plus 25 regulator and a minus 25 regulator. Here's a plus 14.4 volts right there. And various other little things, don't know quite what they are. So let me do this capacitor right here, see how good it is, and resolder it back to the chassis, and we'll see if this thing will do anything. Okay, here we go. Here's the capacitor, or the subject right now, and I'm going to widen you out a little bit. First thing I'm going to do is take some pictures of it. Take me a couple of reference photos, get it off in video. Go ahead and make a drawing of the capacitor. So This capacitor consists of two 200 microfarads at 150 volts and a 50 microfarad at 150 volts. So, not a big deal. The half moon is at 200 at 150, and then the square is also at 200 at 150, and the triangle is a 50 at 150. There's a 680 ohm between the half moon and that. 680, 2 ohm, 2 watt. There's a gray and violet. Right there, then a gray and light orange right here. And the other one is a white and blue. That's all there is to it. Got the soldering iron all warmed up. Zoom you guys back in so you can see what the daylights I'm doing. There's the, so here we go. I'm trying to get my hands out of the way. See if I can use my desoldering solder sucker here. Get rid of most of the solder out of it. Oh! Do y'all see that? Look! That lead just broke right off. I'll be dang. What in daylight is going on here? I didn't do that. My goodness gracious. I swear I did not do that. I don't know. That sure did. That post on that capacitor was either cut off or broke off. I've never seen that before. If it broke off, I've never seen that. I mean, that's it right there. That's the post. Judging from the way the solder is blobbed down on it, wow. We'll just leave that out of the way for right now. Ah, that is a good one there now. Totally wasn't expecting that. Yeah, this capacitor, something's been done to this before. The lead shouldn't have been stretched out as far as it should be. That don't look right. Could be factory, I don't know. Like I say, never worked on one of these before. Yes, I'll just cheat a little bit. All right. This camera's got a image stabilizer on it, so I have to let it do its things before I move you guys. I want a new camera. Maybe I need to ask for one for Christmas. Aluminum electrolytics, and we'll go ahead and do a lead zero. I don't think you have to do a lead zero for such a high value capacitor. But I do it anyway. Short. Alright. So first thing I'm going to do is check the 200 microfarad one. Plug in the voltage levels. The voltage values and the capacitance value. Put our negative test lead here, and we're just going to go on old stubby here. See if it'll work. Press value, and it's showing 54.9 microfarad. Wow. Capacitor leakage. Definitely bad. It's 7.6 milliamps leakage current. So that capacitor is definitely bad. You know what? That was the triangle I screwed up. That was it was 150 volt. I'm sorry. What is wrong with me? God, I'm so stupid this afternoon. That's supposed to be, the triangle is a 50 microfarad. I screwed up. No surprise there. Let's try that again. Showing 55.3 microfarad. That's better. Still got, though, capacitor leakage. Still 5 milliamps of leakage current, 31 K of resistance. So that is definitely, capacitor is definitely not good. So let's change this to 200 microfarad. Alright, let's check the value on it. Showing 280 microfarad. Usually when they check that much significant higher, there's leakage. So let's do leakage. Greater than 20 milliamps, less than 7.5 K of resistance. Well, that is definitely bad. So anyway, where were we? Let's test the capacitor value again. 258 microfarad. So let's look at the leakage. Greater than 20 milliamps, less than 7.5 K ohms. Alright. Get out. In this case, I don't think I'm even going to put it on the Heathkit. I just don't think there's no point. This thing was one of the poorest soldering jobs I think I've ever seen. It's like a fly in here. Yeah, that had not adhered to the chassis at all. Whoever put this thing together did not use enough heat. But I am kind of hate to solder this thing back in. Well, I'm not going to take it back out. So we'll give it a good solder job. We'll put a little bit of fluxy on. Let me clean that off a little alcohol. Let's clean it off. pretend that I care. Pieces of solder. I mean, that's amazing. Okay, got it cleaned off. A little bit of flux on there. A little more than a little bit. Just about out of solder. There's some good stuff too. This is, let's see, what is this? I know it's Kester. 1 pound of Kester. This is 44 rosin solder. Let's see, I can't hardly read it. SN60 PB40. Let's see, 3.3% slash 44. January 17th, 2018. Alright, anyway, here we go. There's a nice puddle there. Ooh, that rosin will make me eat boogers tonight. It's sticking. I can see it stick. Let's get this rosin off of here. Clean it up. Like it laying around in there, it gets corrosive after a while. Makes things just icky looking. Alright. Don't think it's going to break loose. So I'm going to solder this thing back together, hook everything up temporarily, and let's power it up. I'm not even going to get fancy. I'm not even going to get fancy with my soldering. I'm just going to kind of tack solder it. Let's see, the half moon is the gray orange, which is this guy here, and then this one right here. I tell you what, let's do the other one first here. I think it's the white and blue. I'm not going to get fancy, like I said. The triangle, the 680 ohm resistor, basically is powering the 50 volt, the external, the 50 volt DC bias port. Like I said, I'm not getting fancy with this. Hardest part probably is trying to solder that right there. It looks like somebody took a pair of cutters and just snipped it. 'Cause I've never seen one break like that. Wanting to do too good, is it? Nope. They ain't wanting to do too good. Got blobs everywhere. So what I'm going to do is I'm just going to take a small alligator lead. I'm just going to attach it with a small alligator lead, I think. Because this is temporary. You see it didn't even here. I think one thing is the electrolyte, the guts coming out of the back of it. I didn't notice that a few minutes ago. Sure enough, the guts is coming out of this capacitor right here. That's why it's not taking solder, it's because it's contaminated. Let's see if I can get the clip lead on here. Alright. If you don't mind, I'm going to shut you off a minute and I'm going to clean up my bench and get ready for the next one. Okay, I have the device under test right there. And what you're looking at basically is the bottom side of the chassis here. The Syncor variable AC power supply here. And I've got my dim bulb right up here. I've got this turned all the way to minimum output. I haven't looked at the schematic other than to verify the capacitor values. Make sure this is the right one, which I figured it was. But we're just going to power it up slowly. See what happens. So here we go. Run it up to about 50 volts. Not drawing any current, but I bet you it's not turned on either. Yeah, turned on. Still not drawing no current. Yes, it is. It's drawing just a little bit. So with that little bit of voltage on there, would y'all rather see so much freaking glare? Let me zoom that in. Okay, I'm going to measure the voltage rails on this capacitor. There's 25 volts right there. 19 there. Whatever this is supposed to be. 24 there. So it's got a voltage in it. Got a heartbeat of some kind. So I'm going to raise up the voltage. Raise it up to about 80 volts. Dim bulb tester so far is not even lighting. So see what we got now on the 25 volt rail. We had 25 volts on the 25 volt rail. And we got 13 on the 14 volt rail. It should be minus 25 right here. Showing about minus 27. Alright, well, we still ain't drawing any current. Run it on up to 100 volts. 100 volts is still drawing minimum amount of current. I've got some notifications here. Some of these things are working. Let's check that minus voltage again right there. That's minus 25. Measuring about minus 28. That's with 100 volts coming in. Just going to bring it all the way up to it's 117, which is what nominal voltage. So we got about minus 28.5 0.85 volts on the minus 25. 14 volt rail showing 13.1. 25 volt rail showing 27.57. So those rails are a little bit high. Get back up here across this capacitor. Get about 57.8 volts on that side. 57.8 on that side. 35 on that side. Well, I feel like we're going to do a total recap of this bad boy. So, turn it back on. Boom. So, let's see. If I flip these switches here on, all the indicators start to light up. The 308, 358, they don't light up. But I think you have to put it in chroma. Yes, turn the chroma on, it changes. So this would be for black and white, this would be for color. I think. Okay, let's get the voltmeter and let's check the power supplies and see if they're working. How about that? Think that'd be pretty good to do? I guess y'all can see that, I can't. So let's go to ground to the green here, and we're going to do a positive 0 to 25 volts. There you go, you got a 26.4. Flip the negative switch, it goes to minus 28. Well, that does work. So let's go to this other 25 volt supply. Positive, we'll bring it up. So it does go up to close to 30 volts. And bring it up on the negative side, it goes up about minus 28, so that's cool. Finally, the 0 to 50. Goes up to about plus 44.5 volts, and the minus goes to about minus 47.8. I guess that's good. I guess the next thing to do is see if it's got any kind of audio, any kind of RF coming out of it. So let me see what the text message is about. I'll shut you down. I'll get my spectrum analyzer out, and we'll go from there. I'll be back. Okay, I'm going to do this gorilla style, like I call it. No tripod. I got my spectrum analyzer set up. It's a 8568B. This one goes from 100 kilohertz to 1.5 gigahertz. So here's the output right here. Turn the chroma off. Turn the volume level down. And let's just see what we get out of it. I'm going to come in on the secondary port. And let's see, we're going to go from 30 megahertz to 50 megahertz. So let's program start frequency of 30 megahertz and stop frequency of 50 megahertz. Got a nice little something there. Level does adjust. Attenuate works. Let's see what happened. Here is the, turn all these markers off, and you'll see that there's nothing there. Let's turn on the first marker. Right there, that's 41.25 megahertz. Right there. So let's come over here to, where's my markers? Markers. Of course, that says 39.86 megahertz. I'm not sure how accurate this is yet. I'm sorry, 39.75. I stand corrected. So that's not bad. That's pretty close. Let's turn that on. Turn on 41.25. That's not bad. Let's do the 41.67. So that works. 42.17. Okay. 42.67. That one works. Then the 42.75. Let's check out the marker. 42.86. 44. Right there. We'll do the marker again. Pretty close. 45. Alright, 45.75. Adjacent sound, 47.25. That's pretty close. And whatever 100 kilohertz is for. So, let's do a full scan. Let's see, I want to do frequency spin. Let's just do a reset. Like right now, all the markers are turned off. There's no output from this rig. So, mod markers. So let's turn a marker on. Alright, where'd it go? Okay, that's lit up. Oh. Duh. Doing something. 10.7 right there. Channel 10, channel 4, mod marker. Marker. Let's go, where are we at frequency wise here? That's 465 megahertz. I wonder if that's just, let's do a frequency span of about 10 megahertz. We'll do a center frequency of probably what, 25 megahertz. frequency span of 100 megahertz. Let's see what that is. Repeat search. It's about 42.4, showing about minus 10 dBm. So we'll pull the attenuator. It says it should be pull for 20 dB. So if I pull that, I should drop that down to minus 30, and it does. So that's good. So the lowest signal level without the attenuation is about minus 28.6. The maximum signal level out of this is about minus 6.9. If I pull the attenuation, it drops down to minus 26 at the max and minus 48 at the minimum. So change this to IF, and it is sweeping, as you can see. I'll change the time base here in a minute, but if you want to do this, we'll just go over here to max hold. And now you see what it's sweeping. So right now it starts at 37.9, goes to 53.5. Let's do an IF. Let's clear that. Change our center frequency. Amazing what a spectrum analyzer will tell you. Go clear right. See where else this is. Cramping my foot. I think a lot of that's heterodyning. Go back to clear right. Turn all this stuff like off except for let's just do 4167 to 4725, which is adjacent sound. Okay, let's just do 4125. So it should be sweeping, we'll just say from 40 megahertz. Let's do the start frequency of 40 megahertz. And go to what? 40, let's do 50 megahertz again. So it is sweeping. Clear right. There we go. I'm just playing with it right now. clear right. Now I hadn't tested any of this stuff yet, but we'll get to that. So I guess it's doing something. It hadn't let any smoke out that I can see. Filter cap is actually cool. Wonder if this might be one of those things where it reforming itself. Well, nothing seems to be actually wrong with this thing. Just back on clear right. I wonder if we could see this on the frequency counter right here. Now, look, I got a disclaimer too, guys. I have not messed with one of these things, like I told you at the beginning of this video, in forever. So I'm kind of learning this thing, how it works and all this at the same time, trying to figure out what exactly, I know what this is, okay? But I'm just trying to figure out what exactly is it sweeping here. But anyway, let's see if I can make this show up on my frequency counter. Let's do 4167. So 41672. This should be 4267. So I have a feeling in the alignment here it's going to go, we're going to be going through all these crystals right here. And using this very test right here to align this thing, to get every one of those on. So it's not bad. So let's do adjacent with 3975. Alright, let's do 41 and a 4125. Let's do 4167. Uh, 4217, I think. Turn this around a little bit. Okay, 4275. 4400 even. I mean 44,000 even. That's pretty close. 45. That's pretty close. Okay, 4575, I believe. It ain't bad at all. Adjacent sound, 47 and a quarter. That's pretty close. I don't know what this 100 kilohertz does. Well, 100 kilohertz is 97.0978. So that's 97 kilohertz, 97.845 kilohertz. So even that's not bad. There's 42.845, channel 4. Change it to channel 10, it goes up to 69.3. I have to look at my frequency chart, television, to see if that's accurate or not. See what 10.7 does. The 10.7 is showing 9, but I think it's possibly sweeping. Well, I think it's actually alive. I think it's doing most of what it should be doing. Let me turn this spectrum analyzer off. So I think I'm just going to go ahead and order the parts for this thing. It's going to be 1, 2, 3, 4, 5, 6 capacitors and 4 BNC bulkhead connectors. And we'll put those caps in and recheck the power supplies and see if there's any adjustments on there, which I don't see. Then we'll get the service manual and see what we can do about aligning this thing, if it even needs it. This thing be good to go. Alright, so this time it's thank y'all for watching, and like and subscribe please, and we'll talk to you later. Bye bye.